Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing high weightage test 15 most incorrect questions done by the students. This test is based on maxima and minima. Let's see what are those questions. This question says fx is equal to 3x minus 4x cube. Then we have to find the number of solutions to the equation fx is equal to root 3 by 2 in the interval. I can give you 2 or 3 solutions for this. Let's see what are those. The first solution would be that if you take x as sine theta, and this idea comes from this expression because it is 3x minus 4x cube. So if you take x is equal to sine theta, then fx will become equal to sine 3 theta. And dear students, x is also given from minus 1 to 1. That is also additional reason to do this substitution. When x is from minus 1 to 1, then theta will be from minus pi by 2 to pi by 2. And we want this to be equal to root 3 by 2. Okay, now root 3 by 2 sine 3 theta means the value of 3 theta can be found like 3 theta equal to, I think one value will be 60 degree, or you can say pi by 3. In the second quadrant, if you go, it will be, I think, 2 pi by 3. Okay, and afterward also you can find. In fact, one angle will be there in the left hand side also, and I think it should be minus 4 pi by 3. Minus 4 pi by 3. Because theta is from minus pi by 2 to pi by 2. 3 theta will be from minus 3 pi by 2 to 3 pi by 2. And you can see these values are within minus 3 pi by 2 to 3 pi by 2. This is, I think, 240 degree, minus 240 degree. This is 120 degree. And this is 60 degree. And when we say minus 3 pi by 2 to 3 pi by 2, it is minus 272 plus 270. So total number of values for theta we are getting as 3. So answer for this question should be C. One more way you can do this question, please listen carefully. That if I draw the graph of sine 3 theta, and because sine 3 theta is from minus 3 pi by 2 to plus 3 pi by 2, that means it will be coming from this minima, the maxima, and I think it will go like this. You see, this is minus, actually minus 3 pi by 2 will be here. Yeah, minus 3 pi by 2 will be here. So this will be minus pi by 2. This will be pi by 2. And then this will be 3 pi by 2. So the portion that we must be looking for is actually from this to this. Minus 3 pi by 2 to 3 pi by 2. This is graph of y equal to sine x. When x is ranging from minus 3 pi by 2 to 3 pi by 2, which is the range of 3 theta here. Now, for this portion of graph, if you are looking for value of function to be equal to root 3 by 2, that means it should be intersection by this line, which is y equal to root 3 by 2. So there will be 1, 2, and 3 solutions. So total number of solutions are 3, which are in terms of theta also. But because they are asking only number of solutions, I think this is sufficient enough. There is no need to do this thing. If you are okay with this, I think go with this. If you're okay with this, then this is also fine. Now there is one more method which I would like to tell you for this question. That is direct differentiation. So if you differentiate this fx, so f dash x will be equal to 3 minus 12x squared. If you make it 0, you will be getting x is equal to plus or minus 1 upon 2. So this is a graph of cubic whose leading coefficient is negative. So it will be coming from plus infinity, and then it will be going towards minus infinity like this. And this will be the point of minima, that is minus half, and that will be point of maxima, that is 1 by 2. And my interval is from minus 1 to 1. The value at minus 1 is minus 1, and the value at 1 is value at minus 1 is 1 actually, and value at 1 is minus 1. Okay, so this minus 1 should be here, and plus 1 should be somewhere here. Okay, and the value is 0 at 0, and 0 is also point of inflection. Okay, so where the concavity is changing, so the graph will be something like this. Okay, now we can check what is the value at 1 by 2? At 1 by 2, the value is, I think, 3 by 2 minus 1 by 2. So this value is 1 here. Actually, the value at -1 and 1 by 2, they are same. Okay. Now, if we are looking for the value of function as root 3 by 2, so same logic I will give you as I gave you in the method number 1. That root 3 by 2 line will be actually going like this, y equal to root 3 by 2. So you can see from -1 to 1, this graph is intersecting this y equal to root 3 by 2 at 3 points. So number of solutions would be 3 for this question. Now coming to this question, we are given function fx has how many points of local maxima, how many points of local minima. Here I will again give you two methods, dear students. The first method would be just do the differentiation. If I do differentiation f dash, it will be 2 upon 3 and this x square minus 4 whole power 1 upon 3 into 2x will also come in the numerator using chain rule. Okay. Now you can see this f dash is equal to 0 when x is equal to 0, and this is also not defined when x is equal to plus or minus 2. Actually, the graph of this would be, you can see this fx will become equal to 0 at -2 and +2. But from the derivative, we can see the derivative becomes not defined at +2 and -2, which means its derivative actually tending to infinity. So the graph at -2 will be something like this, and similarly at 2 also it will be something like this and going like this. So derivative at -2 and +2 will be going towards infinity, whereas there will be a point x is equal to 0 where its derivative will be equal to 0. Derivative is equal to 0. So now from this graph we can very clearly see that this is point of minima, this is also point of local minima, and this is point of local maxima. So 1 point of local maxima and 2 point of local minima. So that's it. Okay, so that is one method. And dear students, the other method is actually direct. I will not do the differentiation. Rather, what I will be doing, I will be drawing the graph of this function directly. I can say -2 and +2 are those points where it becomes 0. And power 2 by 3, make sure that whatever inside is, maybe positive or negative, it will become positive. Because 2 by 3 means that either first you do squaring and then take cube root, that will make positive, or first you take cube root and then take square, that will also make it positive. So the graph is going to be always positive. Now this is actually having x minus 2 power 2 by 3 and x plus 2 power 2 by 3 as the factors. Now x plus 2, x minus 2 are giving zeros as -2 and +2. But if you look at their power, it is less than 1. If it is less than 1, their derivative, and this can be thought of directly if you are aware of this concept, whenever this power is less than 1 but greater than 0, its derivative will give you these roots as those points where derivative becomes infinite or tending to infinite. So the graph would have been at 2 like this, -2 like this, at 2 also like this. And from Rolle's theorem, between 2 and -2, there has to be one value where derivative will be 0. Now, what will be this point? I don't care, because I just need the number of points. So this will be point of local maxima, and this graph has to be continuous. So it has to be, a point of maxima here from drawing this graph directly, we can say. So 2 points of minimas and 1 point of local maximas. Coming to this question, in which we are asked to find number of critical points. Number of critical points, first of all, what is critical point? It is actually the points where either derivative is not defined or derivative is equal to 0. So one method is that you just take the derivative f dash x, which will be 4 upon 5 x minus 2 power 1 upon 5 into 2x plus 1 plus 2 into minus 2 whole power 4. So let's take this 5 into x minus 2 power 1 by 5 as LCM. This will be 4 into 2, 8x plus 4 plus 5 into 10 into x minus 2. So this becomes equal to 10 plus 8, so 18x minus I think 16 upon 5 into x minus 2 power 1. So this derivative is equal to 0 at x is equal to 16 upon 18. Okay, this is equal to 0 at x is equal to 16 upon 18, and it is not defined when x is equal to 2. So these are 2 points where we have critical points. Okay, dear students, this can be done directly also. Please try to understand. If I draw the graph of fx using wavy curve method, so minus half here, and 2 here. So positive here, but when you cross 2, now look at this expression, power is 4 upon 5, which is equivalent to power as even number, because you will be raising it by 4, then multiplying 1 by 5 in the power. So it is basically always positive. So it is like even power. So it will be positive here also, and it will be negative here. Now, at 2, it has to be 0. At minus 1 by 2 also it has to be 0. Okay, and after that it will go to infinite. Before that, now please see this function between 2 and minus half. It is satisfying all conditions of Rolle's theorem. Both are giving you 0, 0. Between this it will be continuous. Between this it will be differentiable also. So you have to have a graph like this where there will be one point where derivative will become 0. Okay, and after that it will become negative. Now please look at this point at x is equal to 2, which is having power 4 by 5, because the power is less than 1. So its derivative should be such that it becomes infinite at 2. Whenever your function is having some root with power between 0 to 1, you differentiate it, it has to become such that its derivative tend to infinity at that point. So this will be a point of non-differentiability or derivative not defined, and there will be exactly one point between minus half to 2. So 2 point of critical point you can expect it here. If you're not very comfortable with this method, I will say go with first method, because this is guaranteed method where there will be no error, there is no chance of any confusion. But here, if you're not comfortable, you can skip this method. Okay, sum of absolute maximum and minimum value of this cubic. Okay, dear students, first I will like to tell you that you are having choice that you differentiate it and find maximum minima, or you have one more thing that you can do. Just take x minus 2 as t. Okay, then your function will be f of t equal to t square into t minus 1. But then your t will belong to, because t is x minus 2, it will be from minus 1 to 2. Okay. Now you can see by making this substitution, you are just shifting your graph, but value of maximum or minimum will not change. Differentiation will be much easier by doing this method. It will be t cube minus t square. If you take differentiation of this ft, it will be 3t square minus 2t equal to 0 will give you two values of t. One is 0 and one is 2 upon 3. Okay, so this graph in terms of t, because leading term is positive, will be coming like this. Okay, now this 0, the first 0 is coming, then 2 by 3. So at 0, it will be having point of local maximum, 0, and the value of this function at 0 will be 0. Okay, whereas this point here, 2 by 3, which will be point of local minima, will give you value. If you put 2 by 3 here, it will be, I think, 2 by 3 minus 1, so minus 1 by 3, and so this will be minus 4 upon 27. Whereas at minus 1, if I look, the value is at minus 1, I think it is 0. No, minus 1, it is minus 2 actually. So minus 2 will be less than this. So we are getting minimum value here, minus 1 comma minus 2. And at 2, if you put 2 here, 8 minus 4. So at 2, it will be 8 minus 4 is 4. Okay. So they're asking sum of absolute maximum value. You can very easily see that the relevant portion of the graph was this, and the maximum value is coming here and minimum value is coming here, because this is going like this, This is going like this. So maximum is here, minimum here is here. So value of absolute maxima and absolute minima, the sum is equal to 2. So that is one method. Other method is directly that you do it in terms of x. So that way also you can do. Coming to this question where we are given e power y is equal to x raised to the power 1 upon x for x greater than 0, and we have to find the maximum value of y. So first I will write this as y equal to, after taking log 1 upon x ln x. If we differentiate it, we will be getting minus 1 upon x square into ln x, and I think plus 1 upon x square. If we take 1 upon x square common, 1 minus ln x here. Okay, so the critical point here would be 1 upon, critical point here would be e. When this ln e is 1, so 1 minus 1 will be 0. After e, it will be negative. Before e, it will be positive. So this will be actually point of local maximum at e. And they are asking the maximum value. So this e will give you the value of local maximum. And if we put it here, we get, I think, 1 upon e. ln e is 1. So answer of this question will be 1 upon e. Very simple question, simple differentiation. And it has to be done this way because you cannot comment on point of local maxima or minima directly without doing differentiation. Coming to this question, set of all values of k for which the function fx is equal to this does not have any critical point. So does not have any critical point means it should be having no point where f dash becomes equal to 0 or not defined. Now I think we should first find f dash. That will be k square minus 4 into cos x plus k minus 2. I think k minus 2 is coming common. So this will become k plus 2 into cos x plus 1. Now we want this should not be equal to 0 for any x. So first of all, k cannot be equal to 2. Because if k is 2, this f dash will become identically 0. So in a sense, every point will be a critical point. Then if k is not equal to 2, then what we will be needing? We will be needing this should not become equal to 0. So that means k plus 2 into cos x plus 1 should not be equal to 0. That means cos x should not be equal to minus 1 upon k plus 2 for any value of x. So this is only possible if I take minus 1 upon k plus 2 mod to be greater than 1 or greater than 1, not equal to 1, greater than 1. Okay, so let's see what should be the answer for this question, set of values of k. Okay, so this is greater than 1 means my k plus 2 mod should be less than 1. If this is less than 1, k plus 2 is less than 1, I think the value of k should be minus 3 to 1. I think it can be done directly also, or we can do, we can use that property, k plus 2 will be less than 1, it will be greater than minus 1. So k will be less than minus 1, greater than minus 3. So the range of k should be minus 3 to minus 1. Okay, and not equal to 2 is already counted here. So I think maybe there is a typing error here. So answer will be A, minus 3 to minus 1. Yeah, correct. It should have been minus 1 here. So this A is correct answer. Now coming to this question where we are given f r2r as a function given by mod 3 mod x minus 4, and we have to find number of point of local maxima and local minima. Now to do this question, what we can do, we can first simplify this fx, and this fx is given as 2 mods, one of which is mod x, which will be opened with plus sign for x greater than 0, with minus sign for x negative. This will be opened with plus sign for x greater than 4. It will be opened with minus sign for x less than 4. So I can make 3 cases. One will be from minus infinity to 0. One will be from 0 to 4. And one will be from 4 to infinity. From minus infinity to 0, I think inside this mod, this will be opened with minus sign. So minus 3x. This will also open with minus sign, so it will become plus x minus 4. Okay, for 0 to 4, this will be opened with plus sign, so 3x. This will be with minus sign, so minus minus plus x minus 4. And in the last one, everything will open with positive sign, so 3x and minus x minus 4. So let's simplify it further. Will give you, I think in this case, minus 3x plus x, so minus 2 minus 4. So I can write this as 2x plus 4 mod of 2x plus 4 for minus infinity to 0. And for the second one, I can write this as, I think, 4x minus 4 for 0 comma 4. And for this one, it will be once again 2x plus 4 for 4 to infinity. Now, dear students, this case actually can be written without mod also, because for 4 to infinity, it will be otherwise also positive. For 0 to 4, I think this will be opened with both kind of sign, because this is becoming 0 at x is equal to 1, which is lying between 0 to 4. Similarly, this becomes 0 at x is equal to minus 2. So between minus infinity to 0, this will also be having a corner point. Actually, these two will have corner point. This will be just opened by 2x plus 4. So if I draw the graph, because with graph, it will be much easier to look at how it is going to behave. So if I start with this point, so minus 2 from this interval, so minus 2 is the point where this will be having a corner point, and then let me call 0, and then 1, and then 4. So this is how the important points are for this graph. Now from 4 to infinity, I think at 4 value will be 12. So graph will be going like this. Between 0 to 4, at 1, it will be having a corner point, and till 0 also like this. Before 0, again it will be having a corner point at minus 2, and it will be going like this. Okay, the slope can be little bit changing depending upon actual values. You can draw accurate graph, but my point of local maxima and local minima can be observed very clearly here. I think this will be point of local minima, this will also be point of local minima, this will be point of local maxima. Dear student, at 4, if you see, just before 4, the slope is 4, and after that it is 2. So this is point of non-differentiability, but the graph is increasing and increasing. So this is not any point of local maxima or minima. So total number of point of local maxima and minima will be 3 for this question. Okay, so I think this is how this question should be done, because direct differentiation is not possible. You can do one more thing, that you further split these graphs about minus 2, 1, and then do the differentiation. That way you can do it. But I think we know how graph of mod is plotted, where V shape is formed. Okay, corner point is there. So if we use that, I think this is best method for this question. Okay, students, thank you so much.